ఎప్పుడు ఏ ఫార్మర్
Hello. Good evening to one and all. Hello.
Hello, sir. Hello, sir. Hello.
Shiva,
Yes, sir. Good
okay.
evening, sir.
Okay.
Yes, sir.
And what about Punita madam? She has come?
Mita ma'am also available, sir. He
Okay.
already entered, sir.
So, how many participants, sir? As of now?
As
56.
of now, 56 participants.
Okay, sir. Okay.
Sir, shall we start?
Ma'am, only 61 participants have joined now.
I'm
Madam,
not able to hear your voice, sir.
yes, ma'am. As of now, we are having only 62 participants, ma'am.
Okay, sir.
At least one third should be there. That then only we should
Okay,
have
okay, sir.
the
Okay.
program. More than 100, if you have cast, we will start the program.
Okay, sir.
Punita ma'am. Punita ma'am.
Yes, sir.
Kindly start the session.
Sir, sir, shall we
Punita ma'am,
start?
please start. Please
Sir,
start.
shall we start, sir?
Yeah, yeah.
Yes, sir. Yes.
Please.
Shall I start, sir?
Start, ma'am. Start.
Yes,
Okay.
ma'am.
Okay. Good evening, everyone. Today we'll start with day 4 sessions of ATAL FTP organized by Tagore Institute of Engineering and Technology, Devya Kurichi, THALAIVASAL, Tamil Nadu. Now, today our session 7 topic is research challenges of ML based robots, and it will be presented by Dr. S. Suganti ma'am. So first we are delighted to welcome Dr. S. Suganti ma'am,
Yes.
Professor, and welcome you ma'am. Professor and Head of the Department of Data Science, Coimbatore Institute of Technology from Coimbatore, as our resource persons for session 7. She has an impressive academic background with a PhD from Anna University, Chennai, and MPhil MSc degree from Bharatiyar University. She possesses over 2 decades of rich teaching experience at Coimbatore Institute of Technology, where she has served in various capacities and currently as professor in the field of data science. Her research expertise lies in computer science and information systems, and she has contributed significantly to academia through her publications in reputed journals and research collaborations. She has 3 journal articles, with her works receiving citations indexed in Scopus and Google Scholar. She has actively contributed to the academic community by serving as an expert member and a board of studies member in reputed institutions, including PSGR, Krishnamal College for Women, Coimbatore Institute of Technology, and Congo Engineering College. Her scholarly engagement is further reflected through her Vidwan score of 6, along with her strong research presence identified through her Orchids, Scopus, and researcher IDs. One of her notable publications includes Role of Aspect-Oriented Approach and Dynamic Adaptability, published in the International Journal of Computer Applications, which highlights her innovative perspective in computer science research. Her dedication to education, research, and mentorship has made her highly respected in academic fraternity. We are truly honored to have you, ma'am, with us today to share her valuable insights and expertise. Welcome you, ma'am.
Thank you. Shall I start?
Now we'll have the session. Yes, ma'am.
Yes, I can start the session.
Yes, ma'am.
I hope it is audible to everybody.
Yes, ma'am. Yes, ma'am.
Yes. So I am Suganti. I am very much impressed with the is it audible?
Yes, ma'am, you are audible.
Okay. I am very much impressed with the Punita madam who has given the introduction about me. And also, I am very much honored to the organizing committee for inviting me for delivering this session on research challenges of machine learning based robots in this event. Research challenges of machine learning based robots. So I am Suganti. I am the professor and Department of Computing and Data Science and Coimbatore Institute of Technology. The next slide is shows how the machine learning has been used in determining the prediction of various aspects. So for example, the machine learning is subset of artificial intelligence, and also we are having a learning agents in artificial intelligence which has been defined by supervised learning, unsupervised learning, reinforcement learning, and all these three comes under machine learning. So this is what actually about the learning agent in artificial intelligence, which could also be used for handling the robots. So actually, I used to say to my students such that we are not developing it as a statistical techniques. We are developing it as a machine learning techniques which can comprises of statistical learning techniques plus computational techniques. So that means without software, we are not doing anything by making use of the statistical techniques. So by making use of the statistical techniques only, we are going to predict the domain or predict the problem which has been given in the domain by making use of the machine learning techniques. So this is what I want to say. So since already aware of the machine learning, I am not going to much discuss on these machine learning techniques. The next slide is on machine learning based robot. So here only I am going to focus more things. So we need to make a robot which has to learn from ML. As I already mentioned that robot could also be an intelligent based system. That means we are developing it by making use of a learning agent. So the learning agent, in the sense, we are going to make use of this robot in machine learning. So that's what I have mentioned, that so it has to learn from the data, and also it has to learn from the experiences to perform the tasks without pre-programming. That means, so we are not going to do any pre-programming. We are going to incorporate the performance of the robot to be enhanced, to be improved by making use of learning the robot, by making use of the data that has been extracted. So that's what I want to say. So as I said that, so I'm going to have a training data set which can be used. Sorry. That's what I asked you, whether I have unmuted or muted. So is it audible or not? Okay, anyhow. So I have unmuted. So now I think you can able to hear what I'm saying to you. So I have mentioned that the robot is also a system which has to be learned from machine learning. And also, as I said, that machine learning is the life cycle of the machine learning can be defined by extracting the data or collecting and extraction of the data to the analysis of the data. and also the inferences should also be incorporated, so which can also be considered the decision learning of the robot. So this is what I want to say. So this is what the learn from data and experience to perform the task without pre-programming. So this is what the machine learning based robot represents. Then training data which can be used. Data set is nothing but what we have extracted from the experience through which we are going to define the data set. For example, when if you are going for the robot and if you are going to take the data set which can be used as moving the, for example, you are taking a robot which has to be clean the rooms. So I am going to take how the movements of the data could be and where the robot should be located, where the dirty elements should be located. So all those data are extracted and to be collected and which are considered as a training data set. Before that, I can make use of the feature extractions by making use of the principal component analysis method. So by using that, I can able to do the feature extraction. So that's what I can, I'm doing it, and I'm going to give it to the machine learning techniques, and I'm going to predict what actually the whether it has been sucked all the dirty elements and where the dirty elements could be, etc. Okay, so all those things could be generated from the machine learning algorithms. So this is what I can say, that unsupervised and supervised learning algorithms plus the reinforcement learning algorithms, which can be given to the feature extraction, and again it has to be given to the machine learning algorithms, and for grouping of the objects. Since it's unsupervised learning, it's a grouping of an objects and the prediction model which can be used. So this is what I'm going to say, and also I can make use of the new data set which can be considered as a test data set, and on which we can able to infer what actually the prediction should be done. So the next slide is supervised and unsupervised learning. As I said already, so robot is trained on a data set. Yes, of course. Without a data set, we cannot able to make any training. Predict the output. Yes, already I have mentioned that we have to predict the output for new data set. That's what I say. I told you that test data set. That is new. I have mentioned that is nothing but called as a test data set or for unseen data set. So we can extract the data from the population and we can able to extract. So there are two things that statistical information can be defined with respect to the two data sets. One is the from the population we can have it, or one from the sample. So sample data are nothing but what we are going to have the random sampling, and by making use of the random sampling we can able to extract the data. So this is what already we have done. So this is what I have already given. Okay, predict the output for a new or unseen inputs, and this is used for identifying the defective part of an assembly line. As already you know that in assembly line or in manufacturing unit, we can make use of the robot to determine the quality of a parts which are being produced by the industry. Okay, so that's what. So, and also I can able to take in supervised learning, I can able to find the defective parts. How I am going to find the defective parts? I can take a image of the parts which are being produced, and that image can be sent to the
Not audible, ma'am.
Okay. Now I have clicked the audio. Okay, fine, good. So that's what I am doing it. I've already informed you that the defective part of an assembly line can be identified by making use of the supervised learning. The next one is the unsupervised learning. Again, we have to make use of the unsupervised learning for training the data, and again we are going to do all the feature extractions, and we are applying the unsupervised learning techniques in order to grouping the similar items or in order to detect the anomalies. So both the things can be given here. So robot analyzes unlabeled data, and that the unsupervised learning, it's not going to be a non-parameterized. Okay, it is so I'm not going to say the parameters and non-parameters. It should take a different way. So I'm going to say only the labeled or unlabeled, or the output is given or not given. So if output is given, then we can consider that as a supervised data set, and if an output is not given, then we can take it as an unsupervised data set. So the robot analyzes unlabeled data and find the hidden patterns, and we can able to group the similar items or anomaly detections. I'm going to the next slide, and the next slide is reinforcement learning. Actually, the for robot, the mainly used learning technique is reinforcement technique. That means the reinforcement will give the award for the success. So the robot, when it, suppose if you are going to have a vacuum cleaner robot, and which has to maintain the rooms as a very clean, and if the robot is going to suck the dirty elements in a proper way and fully, or otherwise I can consider it fully. So 100%, if it is able to suck the dirty elements, then I can consider that as a 100 credit points I can give it to the robot. So that implies the rewards. So that's what here we are going to have the input raw data, and it has to be given to the state or agent as a state, and also I can go for the selection of the algorithms and the best action to be taken, and I can able to give the reward for the complete sucking of the dirty elements. So I can able to give it like this, and which can able to give the output. So this is what the reinforcement learning. As I already mentioned that reinforcement learning plays vital role in robot, based on the rewards or the credits which we are going to pay for the complete section of the robot. So that's what 100% credit points we are going to give, or 100% reward we are going to give. That much we are going to give it for the sucking of the complete dust particles by the robot, that is vacuum cleaner robot. So that's what here is given. Okay, so the environment specifies the room, and also where the dirty elements and where the vacuum cleaner robot will placed. So both things will specified as an environment. Okay, let's go to the next one. I hope this is already we are aware of it. And all these things are which we are, whatever I'm going to say, which we are already learned, and which can be known to us. So reinforcement techniques in robots. So there are the value-based methods, policy-based methods, and actor and critic methods. So likewise, the three techniques or three methods can be used for robot for the replacement algorithms. Okay, so this is what we are having. We are having a value-based methods. So you know very well that in reinforcement learning, policy, which is going to be the function that maps states to action. So S to A, B from S to A, or the policy P from S to A. So this is what we are used to have it, and focus on learning a value function that estimates the expected future reward of being in a particular state or taking a specific action in a state. So this is what we used to call as a value-based methods. So the value-based methods are going to award the rewards which is going to be called as a value function. So the Q learning is one of the reinforcement techniques that we can use it for this reinforcement, and which can able to an algorithm that learns Q function, which represents expected cumulative reward for taking a given action in a given state. So this is what the Q learning. And deep Q learning, that deep itself implies the deep neural networks, and which is the subset of the machine learning. And also as a subset of the artificial intelligence. So artificial intelligence in turn will make use of the learning agents, which can also be described using the deep neural networks. So that's what here it's well. So use of the deep neural networks to approximate the Q function, allowing it to handle the high dimensional state spaces. So like deep Q learning could be used. So value-based and policy-based techniques. Here the policy as a function that maps states to action, and also we can say that robot learns the controller that dictates the best action to take given the current state to maximize the long-term rewards. So this is what the policy-based methods and actor and critic methods. So we used to have the critic, which will be considered as different from the teacher. Okay. Critic learns the value function to evaluate the action taken by the actor. So here we are not aware of how the action has to be done. Okay. So that we are not aware. So that's what here the critic and actor learns and updates the policy. Anybody who learns and updates the policy can be considered as an actor, and the value function critic is one component which can learn the value functions to evaluate the actions taken by the actor. So this is what the reinforcement techniques which are available. And another thing is what I want to say, because as I said that deep Q learning, so that encompasses the deep reinforcement learning also. So I would like to specify the working of the deep reinforcement learning, because using the deep reinforcement learning, only the robot can take the environment and it performs the action based on the environment. Okay, so that's what, because an agent will consist of both things. One is the it perceives the input, and based on the environment it takes the action. So both the things will be in the robot. Okay, so that's what I would like to go for the next slide. And there the working of deep reinforcement learning could be done. And here how actually the working of the deep reinforcement learning could be done is given here. The first one, as I said, that as you can take a system could be the robot can interact with an environment, as you know very well, if it is going to be a medical diagnosis system, then the environment could be the doctor, patient, the hospital, and so on. So that is what, and also the reports that are being generated. I mean, the MRI report and CT scan reports likewise. So that's what they're given here. And another thing is the agent observes the current state of the environment, as already mentioned that since an agent will consisting of both the things. One is the perceiving percepts. One is the percepts, another is the action that it has been done based on the environment. So this is what being done. So the agent observes the current state of the environment. Okay, so by making use of the input that it has been received. It can also perform the actions based on its current policy. Since it's a reinforcement learning, so I have to mention about the policy and value, so that policy is the one which can able to map between the state and the action. So definitely we have to perform the action based on the current state also. Okay. The current state is nothing but what the input that we have received. Since all those things are being available in the environment as the facts, and also the rules which are being stated in the environment are nothing but the state and the action, the mapping between the state and action, the function that can map the state and action. So that's what here we are having. And the environment transitions to a new state. Of course, there is a, as I said, no, now we are having rules which can go to map the state to the action. So based on the action, we may be getting into the new state. Yes, that's what. The environment provides a reward or a penalty. Of course, as I said, no reward or not only the rewards alone being considered to be given by the reinforcement learning, and also we can also expect the penalty also to be given based on the action which we are taking. Since the vacuum robot which is not going to suck all the dirty elements, then we can able to mention them as what negative, or the penalty which may be given for it. The agent updates its policy to maximize the rewards through a process of here. Why it is called as why the deep learning has been used for reinforcement learning, in the sense we may take the trial and error and we may try to maximize the rewards based on the process of trial and error. So that's what this deep learning network has been used. Repeatedly, a recursive algorithm could be used here in order to make the rewards to be maximized through the process of trial and error. So the above as I said, no, the above mentioned steps could be iterative. Okay, so until we are going to get the desired behavior. So that's what this working of deep reinforcement learning could be given. Applications are nothing but autonomous applications for the machine learning, which can be used for robot, can be specified here as autonomous vehicles, manufacturing and industrial automation, healthcare, logistic and warehousing, human robot interaction. You know about autonomous vehicle, even the unmanned drone should be considered as an autonomous vehicle. And manufacturing digital automation, of course, you are having, as I say, we can make use of for improving the quality of the products in the assembly line. So that can be considered as a manufacturing and industrial automation. And healthcare, of course, we are having a robot which can be used for surgery. Okay, that, and also instead of patients, instead of doctors, it may give some suggestions about the disease that a patient is having. So for that, a robot can be used. Such a robot can be used for assisting the doctors. So doctor assisted robots can be used. And logistic and warehousing, of course, how to deliver the products on time. So for that, a robot can be used. Even for picking up the products in the warehouse can also be used. Human robot interaction, of course, it's very difficult to have a human robot interaction because you know very well, we have seen in a picture where we are having how the human should not be interacted with the robot. So that we have already seen. So for example, if a human robot is playing a vital role like in enhancing the quality of the product. So while the sensor will be a camera and through which it can take the picture of that object and it has been sent to the, that's what in deep learning neural networks. Okay. For that, what will happen in the sense? The human robot, as I said, we are having a robot, and when a person is trying to interact with the robot, there is no safety handling in that robot. So we must ensure the safety measures in human robot interaction. So that is the main thing that we are, because if a robot is going to be a human, it is going to perform all the human assisted one, okay, or otherwise it can perform all the quality control aspects, and in warehouse it can take up all the things, all the products. So likewise it is going to go. So we have to inform everything to the robot through the software, that the software will maintain it as an some data in a knowledge base or database, whatever you are having, or JSON file. So something, it has to be maintained it, and the proper information has to be sent to the robot by the human. Okay, so that's what I have told, that human robot interaction should be highly secured one. I think I can go for the next slide. So here I am going to make use of the research challenges of ML, machine learning based robot. Okay, this is what topic which has been given. So far, whatever I have taken already known to you, but anyhow, as what I can say, a revision of all the concepts that you have learned, I have done it. Okay. So here, the research challenges on ML-based robot. So what are the research challenges? So many researches that ML can be done, but what are the challenges? Of course, in general ML, there are so many challenges which we are going to take. One is the main thing is data privacy and security. So for whatever the data which you are using in a private mode should be secure enough. So that's what the main challenges on ML. Okay. And also the another thing is like when the execution of the ML techniques should consume less computational power, less power. So that's what another challenge. So these are the challenges which can be existing and ordinary ML, but in robot, how the research challenges could be there. So let us consider here the data requirements as one of the challenges that we can able to specify, and also the since this as I already mentioned, when the data is more and a large data set can be used for performing the machine learning and deep learning in a better way. So that's what here also mentioned. So the data requirements should be complete, and also it should cover the large data set. Then only I can able to make use of the ML and DL here, deep learning. And also when I'm talking about the computational performance cost, again I can mention many things. As I already mentioned, when I'm going to do the large data set using ML and DL, I have to ensure that execution time should be reduced, or otherwise the computational costs should be reduced. So that is the main thing that I have to. So nowadays it is not a big task because GPUs are there. So by making use of GPUs, we can able to execute the learning or deep learning techniques within a short period. So that's what here I can mention. As I mentioned about the safety and explainability, and also I can say that one more thing, as I said. So all these are being considered as research challenges, since as I said, we have to provide the as the data requirements, we have to provide the more privacy on the data. So here the privacy of the data in terms of the healthcare robot, it is essential. And also, so that is what I can consider, and also I can consider the computation and performance cost, and also the safety and explainability. Also, I mentioned that safety is something that what when an interaction between the human and robot has been done, then there should be a high safety, as I said, no, like in assisting the patient. When a robot is acting as assisting the doctor. So that means when if it performs as assisting the doctor, then the correct information or the correct knowledge should be given to the robot for diagnosing the symptoms correctly. So the symptom, and also we can able to make use of the robot for analyzing all our MRI scans and CT scan images, so that it can also say how our MRI and CT scans could be look like if I'm going to have this particular disease. So that is also being, so that means the safety in the terms of what to be provided for interaction between the human and the robot. So that's what I can say. And also I can say the software should have the simulation software should match it with the real-time systems. So the simulated software should match with the real-time systems. And this is what the height challenge. Okay, that, and in explainability, I can able to mention one more thing as what the black box and the deep learning will act as a black boxes. So it is very difficult to identify the errors which may happen within the robot. So that's what happen. And real world complexity and adaptability can also be performed. So these things, the real world complexity and adaptability, like a robot definitely will have the adaptable to the environment, and also it should have a complex data set. So this all these 5 we can consider the research challenges. So in all these 5 areas, we may required some sort of researches that can be done on these things. The next slide is the data requirements, so I can able to mention that one. So ML models are heavily depends on the large and high quality data sets. It is not simply the large data set which we are going to gather or collected them from our experience. That is not the thing. So it should be high quality data sets. As I said that when you are ensuring the quality of the product, it should be a high quality data set. So if the sensors, when the cameras, okay, sensors are nothing but the cameras which are going to take the photos and send it to DL model, deep learning model, in order to identify whether there is a defect or not. So in that case, we need to it should be high quality. The thing is like high quality cameras should be handled, and also when inside the, of course, the deep, you know very well about the deep learning will make use of the neural networks. So multiple perceptrons could be used. So there we may have the many neurons which may highlight both the hidden neurons, input neurons, output neurons, are all there. So all those neurons input neurons should be of the high quality data sets. Input neurons and hidden neurons should be of the high quality. And gathering real world data for all scenarios is time consuming and expensive. So this is what highly we have to consider. When if you take any real world scenario, of course, people are well aware of, like the healthcare scenario, like there we are making use of the robot for surgery, and also we are making use of the robot as an doctor assisted one. So in that case also we have to gather the real, that the high quality data set is also required, and also the real world data set to be gathered, because then only the correct output can be predicted. That means when we are going to take the diagnosis of symptoms of for the patient, we can able to do the diagnosis in a proper way. So once if it is going to be high quality, and also it should um, real world data. So getting, and also it is very time consuming. So how to reduce the time consumption and expensiveness is also a challenge. Also, we can able to consider that as a research challenge. Which one? The time consumption and expensiveness of the data, which are going to be required in order to perform the ML models on the robot. And also the enable to take model which are going to be trained in simulating the data set, fail to transfer to the real world. Of course, this again I can consider as what the simulation to the real world gap. So there I can able to mention the same thing as what model trained in the simulation failed to transfer to the real world. We can go to the next slide. Next slide is the computation and performance cost, as I already mentioned earlier. Training the complex model requires computational cost. We know very well, because the software computation consists of mathematics, statistics, and computers. So all those things are being given here. So anyhow, training complex models requires computational cost, and running the training models in real time requires computational power. Because when if you are going to train the models, it requires computational power. So we need to reduce, optimize the power, so that the challenges could be optimizing the power, optimizing the computational power. So hardware for training and deployment can be expensive. So as I said, no, when if you are going to make a doctor assisted robot, for which the enough expert systems should be loaded into the robot, for which both hardware and software should be highly required. So that's why I told you that the hardware for training and deployment can be more expensive. So for making the robot to be a doctor assisted one, for which we are making use of the controllers and which may be required for training. So which may be considered more expensive. And inference and real-time decision making can be slow. since, as I said, the performance should also be improved. So the computational power should be optimal or reduced, and performance should be improved. When I am talking about the cost, both the things should be reduced. Am I right? The inference and real-time decision making can be slow. So this is what I can say, that inferences and real-time decision making can be slow. High computational leads to energy consumption. As when I mentioned that energy consumption, that implies the robot, which when unmanned drone robot, which can be used to fly and detect the objects in the location. So that unmanned vehicle can fly only based on the battery that it's having. Am I right? So that's what energy. So that's what energy consumption related one. So high computation leads to energy consumption also based on the this one. Which one? The battery power. Okay. So the battery power should be increased. So this is what. So all these research challenges could also be met by us. Or otherwise, in all these areas, the researches could be done. Okay. Or could be performed. A lot of areas, as I said, that in data requirements area, so we may try to collect the data which can be delivered to the model so that it could be large data set. So that how to collect the data from the real world for the robot, based on all these things we can able to perform. So based on all these things, research can be performed. So in all these challenges, which can be used for the researchers. A researcher is not one who is doing the research alone. Okay, even as a professors, we are also as a part of the researchers, so we can also do it. Only the research scholars alone being done, it cannot be happened, because all these challenges, when actually the research scholars can able to take and met it. Okay, that it's not possible. So this is what I would like to mention here. So all these challenges could be used. And next challenges could be the next slide, and safety and explainability. As I already mentioned many times, a small change in the vision input causes heteroscopic action. Okay, so small change in input will make a high variation in the action. So that should not happen. Okay, and also, as I said, no, where actually when we are making use of the robot in logistics or in warehouse. Okay, logistic, leave it. Warehouse, of course, where we are picking up all the products and placing it in the location. The positioning based products. Okay, so that's what we are having it, and in that case I can able to make use of more safety there. Okay. And explainability, as I said, no, we cannot able to diagnose and debugging the problems if we are working in a deep learning models. Since deep learning models are the black box. Since, of course, who are into deep learning models, those who are really implementing the deep learning models from the scratch, then they can able to understand how to diagnose the problem and debugging them. Whereas when a pre-programmed model could be used, then these two things cannot be done. So that, of course, we need to mention this. So this is one of the area that we can able to focus more on doing the research. Okay, when you are providing the safety and in deep learning model without using the pre-programming model. Okay, the software tool which are they used to say that this is a pre-programmed model, in the sense like CNN, what is it? Convolutional neural network is already being defined as a pre-programmed model. So, which is underlying model. Based on that, all the things upon which the other things have been defined. So that model should not be used. Okay, that's what they are telling. So that means we are these things we can able to consider for the research. Another thing is another next slide. Next slide talks about the simulation and real gap. That sim represents simulation and real world gap. So how the simulated environment, how it creates a gap for the real world problem. That means a robot, how it has been considered for the simulation, which can have the gap in the implementation and deployment of the simulated model in the real world. So that's what here we are mentioning here. The model trained perfectly cannot fit to the real problem. Okay, when if I am going to train a model by making use of the deep learning neural network, that cannot be fit to the real robot. Okay, so that how to reduce the gap between the simulation and real, that we need to think, that we need to research. Okay, so that is what here we are taking. And also it's finding that inaccurate modeling finds extremely difficult to model precisely. That means when I'm going to make use of the simulation, I'm making use of the for the simulated environment, I can make use of the machine learning model. So that modeling which is being happened, and when if I'm going to deploy that simulated model to represent the real world model. That means the robot which are going to pick up the parts are modeled simulation using a simulation, and which can be used here as a, of course, by assembling all the parts or all the components in the hardware side. Okay, and also in the software side also I'm going to do something. So I'm going to make it as a real-time robot which can be able to pick up the components, pick up the products in the data warehouse. So in order to make that, we find it's very difficult. So when I'm going to have the simulation to real time, is very difficult to manage the gap between them. So I have to reduce that gap. So that means the researchers should focus on reducing the gap between the simulated environment and also the real world environment. So this is what actually being happening. Next slide. I can go for the next slide. Yes. Real world complexity and adaptability. If you in real world, our robots are very complex to manage. So that's what. So real world complexity, and of course it's adaptable to the environment. How a human can able to work. We are working in an environment where we can adaptable to that environment. So that's what we can able to persistent our task, our job. So that's what here also any robot. Of course, the robot is all also doing all our work. Am I right? When I'm taking the autonomous vehicle driving system, so it is unmanned, autonomous, so unmanned vehicle driving. Of course, there could be some robot inside which we can able to use it and it can able to do all the things. Okay, that's what we can do. And also I can say that so that the what actually can be done, of course a robot could be placed and it can able to have the sensors as giving the inputs to the machine, and also it can able to turn, make use of the gears and etc. It can able to perform the actions. So the actions based on the keys, changing the keys, may perform the actions are by having putting the brake, it can able to perform the actions. So whatever. So all these things are being done as what a human can be done. Also, it can able to manage what are all the vehicles which are being in the road when this unmanned or autonomous vehicle has been passed. So that means it has to see all, so through the cameras, okay, input 60, it has to see all the four sides, it has to rotate and it has to identify which vehicle and which person is being located in which area of the road, etc. has to be considered. So that, so this is what the environment can able to do. So what action is also based on the state currently, the location of vehicle, or the location of a person who is coming along with the past week, unmanned autonomous past week. So that's what the thing has been. So that's what the environment can be done. So this is what I can able to say it should be adoptable. Okay. The first one I can mention that real world is unpredictable, messy and dynamic. And also the robots should perceive their environment in noise and lighting variation. So then of course um, when if you are going to have a robot in industries to maintain its quality of the parts which are being produced by the industry. That means it should detect the quality of the parts that are being manufactured by the industry or that are being produced by the industry. That means the camera should have a clear picture, should take a clear picture of the, so that means high quality picture. So that's what the quality data set there it comes into the way. So all are related to each other. So when I'm saying that, when I'm going to take quality pictures, then only it can able to detect whether I can consider that as what the product which has been manufactured by that industry is quality or not. So that based on these two things. Okay. That's what here, as I mentioned here, like a noise data cannot be used. So it should be a noiseless data. Okay. And also when I'm taking, by making use of the camera, I'm taking a picture of an product. It's the small light variation should light. Okay, the variation should also being considered, and also we know very well that
पापा को मुंह कर दो
hello. So that's what I can say. So lighting variation. So in the sense what the in a dark place or in a dark mood a camera could be, and if you take a picture of the product, that we can able to identify that the product is not a quality one. So that's what I can able to mention here. So that's what here. As I already mentioned that suppose if there is obstacles, for example, I'm taking photo of each product which has been in the assembly line, then that each product should have some gap between them. Okay, so that our camera should able to take the pictures, since it is called as a sensor for our robot. Robot cannot, so only the through sensor it can able to get the input. So that's what. So there should not be any obstacles, in the sense what there should not be any mismatch between the two mismatch between the distance that the two products can come. So that's what I can say here. And also already I have mentioned in reinforcement learning and working aspects of the deep learning also I have mentioned that unforeseen situations. So unforeseen situations, as I already mentioned, this is also an unforeseen. Which one? When the two products without a distance, if they come, then the particular camera cannot take the clear image or the picture of the product. So that is what being done. Okay, so that can also be called as an obstacles and also considered as an unforeseen situations. So in all these areas, I'm expecting that the researchers may do the research for machine learning based robot in these research areas. And I can go for the next topic, next slide. And research areas where actually you have to concentrate more on the challenges of the ML based robot. So we have to take care of more on data efficiency. So this is not happened only by making use of the small set of data. So only the large data set to be used and high quality data set to be used. And also I have to take the self-supervised learning methods should also be applicable. So this is what the area that they can manage. Okay. So developing the techniques that learn from less data. Okay. So I have to mention one more thing as what instead of since it's a very difficult to get large data set with high qualified one from the robots. So as I said that we need to represent that as a research challenge. So that I can represent by making use of the less data and I can make use of the self-supervised learning. So instead of having it as a non-self-supervised learning, I can make use of the self-supervised learning techniques. Okay. Supervised is a teaching learning technique. Okay, that we are cleared with the supervised learning technique. So we know very well about what could be the output. So based on that, the supervised technique could be used. Okay. The next one is what I have to give the simulation to real transfer. So improved way I have to give the simulation to real transfer. That means what? Creating realistic simulation. So simulation should be realistic. That means what? It should, for example, if you are going to simulate a queuing model, otherwise, I can say like this, if you are going to simulate a logistic model, then the real transportation model should be handled in the simulation. Okay, that's what the creating real. So that is the way how we can able to represent the challenges. So I have to make an efficient data. So in research area, otherwise, the challenges which I have mentioned to be addressed using these ways. One way is data efficiency. So that way I have to make use of the efficient data. Techniques, we have to develop the techniques for making use of the less data, and also we have to learn the less data by making use of the self-supervised learning. Also, I mentioned that simulation to real transfers, we should make realistic simulations. Okay, so creating realistic simulations which could be useful for improving the simulation to real transfer. And also I have to develop the better methods for transferring models from simulation to reality. So we have to consider which is the better method for transferring the models. So that is one more challenge which are being occurred here. And human robot collaboration. As I already mentioned many times, so designing systems where human and robots can work together safely and efficiently. So that is the main thing that we have to take, safely and efficiently. Okay. The fourth one is ethical frameworks. Of course, we have to make use of clear ethical guidelines in doctor assisted robot. And ethics should be used. Okay, without ethics, it cannot happen. So, develop clear ethical guidelines, technical solutions for safe and fair robot behavior. Another thing is explainable AI. You know very well about explainable AI and the large language models and transformers and etc. So by making use of all those things also we can able to make researches where we can able to make the robot more transparent and interpretable. Okay, so by making use of this explainable AI and also by making use of large language models and transformer models, etc., we can able to, and also the agentic AI, main thing is agentic AI. So agentic AI will also help us to make the robotics more transparent and interpretable. So I hope I have cleared all the areas which are concentrated more for researchers. These are all the various things which I have taken. And finally, I would like to ask, is there any doubt with respect to the discussions which we had? If any queries, you can mail me to the suganti@cat.edu.in. So this is my mail ID. So I'm asking you to mail. Any query if you are having, you can mail to me. So thank you. If you have any
Dear
queries,
participants,
you can ask me. So that's what I have given.
dear participants, it is the now time for discussion. Please ask your question or submit them via chat box.
Many of you have joined in online, so I hope so. The questions could be asked. And only that's our interaction between the resource persons and the participants could help to work out. So I'm asking you to ask the questions. One of you.
Participants, do you have any questions?
Okay. So you may ask the questions so that the gap between resource person and the participants will be reduced. As I mentioned, no, the gap should be reduced. So that's what here we can able to do. Anybody? Are you able to hear what I said? I said thank you. given.
Yes,
We are
yes,
able to
ma'am.
hear you, madam.
Yes.
Everything is clear and crisp from your side, madam.
Yes,
We clearly understood.
I'm not
Yes,
a
ma'am.
theory.
Yeah, ma'am. I have one query, ma'am.
Yeah,
When we concentrate about rovers, that is called a space robot.
a space robot.
Yeah. Can we implement some machine learning techniques in space robot, ma'am? Is it possible
Yes,
nowadays?
yes. To optimize the route, we can able to implement the machine learning. Optimization
Mm,
can be done by making use of machine learning techniques.
okay. Uh-huh.
Okay.
Thank you, madam.
Okay.
Thank you very much, ma'am, for
Okay.
your
Thank you.
valuable presentation and for sharing your knowledge with us.
Thank
Thank
you.
you,
Thank
ma'am.
you. Thank you.
Dear participants, the next session will start exactly by 7:35 p.m. Kindly join on time. And also kindly fill the feedback form which is available in your WhatsApp group.